right now we are working together at Taipei, and I'm gonna talk a little bit about that project also. Today I would like to talk to you about, basically I'm gonna show you now how to cut and record with this stuff as a kind of a performance. But at the beginning I would like to briefly explain about my background, and I also would like to introduce myself. Maybe some of you already know my school, the GIA Institute of Advanced Media Arts and Sciences, and I also would like to talk about briefly about our sound programming environment, Max MSP, with some example from my past work. Then I'm gonna show you how we do cut record with these personal fabrication tools in a style of performance, and I'll explain a little bit about the background of the work, and we will have some session to talk to each other about question and other stuff. Okay, so this is me. So right now I'm 36 and I have family. I think my boy and my wife is around there. I'm not sure. And they're really.
You want to invite them to come over?
No, it's okay. He's too loud. And he already knows how it runs. So, and yeah, basically I was born in Japan, and Fukushima. I was born in Fukushima actually. Right now my family is not there, but we are kind of close to the stuff. And basically my background is acoustics. Acoustics is my background, and I do acoustic design, my bachelor and master, and then I spent some days at IBM, one of the biggest computer company, as a software engineer, but it's not so much interesting for me at the moment, so I decided to quit the company and to re-enter the school to do kind of interaction design stuff at Tokyo University. And after that, I spent some days at UK and some days at Tokyo, and yeah, at the moment I work at the Tokyo University of the Arts in Japanese names Tokyo GIA, and at the moment I invited Toyoda-san to teach with us to do the sound, grasshopper and the atmosphere stuff for traditional art students, and I moved, but they are still teaching up there with architecture and design students, and they had a really nice exhibition at Tokyo. It's really, how can I say, really kind of a good experience for me at the moment. And from the 2012, I moved to EMAS and teach up there. Okay. And first, I just quickly explain about EMAS. Maybe some of you already know that. Have you got the lecture of the Shaolin Ma, Shiya Kobayashi? So, EMAS is a very small graduate school in the middle of Japan, Gifu, Ogaki, and Gifu is between Nagoya and Kyoto. Kind of middle of nowhere actually. In front of my house we have rice fields and lots of frogs and other species, very few people. But there we have a really good new media graduate school, and we started the school from 1996. And right now we have just master course for 2 years, and we have around 40 students with 19 faculties, so it means that for us it's really good because we just need to have a class around 1 or 2 in a semester, so we have lots of time to do our own work, and it's very unusual in Japan. I'm not sure in Taiwanese situation, but yeah. Okay, and I'd like to introduce some of my colleagues. They are really good. So at first, Shaolin Ma in the Taiwanese, and I suppose that he had a lecture here in the beginning of this year. And I'm not sure how many of you know Arduino.
Arduino. How many of you know Arduino? Raise your hand.
Maybe 30%.
One third to about half.
Okay, so if you know Arduino, you should know GL. He's the developer of the Arduino FIO, the Zigbee wireless Arduino stuff. And he also wrote a book, Prototyping Labo. And fortunately, you have a Taiwanese version of Prototyping Labo, so you can easily get it at the bookstore. And it's kind of a recipe for, how can I say that? Making the moving and the sensor stuff with Arduino. And it's really nice book and it's very easy to understand and read. So if you don't know him or Arduino, please check that book. I just would like to show you an example of how could we use Arduino with wireless connection. So this is our students' work. Esper Domino is the name of the work. And it's kind of the magical domino. Maybe you know the domino. This is the work. So basically, within the domino, we have Arduino FIO here, and we have a wireless connection between each other, and you could easily calculate the order. But even if you know the background, it looks like kind of magic. And you could change the order by shaking. So with the tiny LED in the order. And he did it with accelerometer. And you also could combine the domino with standard one. Or, yeah. Yeah, embrace. Okay, this is one of our students' work. That's right. And this guy, his name is Akamatsu Masayuki. He's really famous for how many of you know iPhone? I suppose almost everyone knows iPhone, and he's one of the first iPhone developer in Japan. He's really good in maybe you know the iPhone application world, Sekai Camera World Camera. It's kind of AR application. So if you could put the many tags in a real space. And recently he's doing he's still doing the AR stuff, and this is one of his recent work, and it might be nice to see. So. He is also really good in Max and but we're going to talk later about Max and SP, so you don't need to. Maybe we could talk. Basically, it's AR application, and you could have some moving images from very traditional, like Vermeer's Roman or Mona Lisa. You could have the moving image from that kind of static images. And recently, he did the work at Seoul, in the center of the Seoul, and he's really good for. Not only for making application, but he's also really good for doing a kind of the business with that stuff. So some graduate of his course start the venture company in Japan, and they are really good with using that kind of stuff. So they're not just doing data research stuff, but also doing kind of the design and business kind of stuff.
There was a game developed, interactive game developed for
Tokyo McDonald's campaign.
Sure.
Where they
Maybe they are related.
is
Not sure. But maybe yeah. The field is not so big. So yeah, please ask if you have any question. Please interrupt me. And the third one. So his name is Ryota Kubo. He's more like an artistic guy. And yeah, I don't need to talk much about his background, but I could show you one of his recent work. Hope it works. Okay.
this was in
Yeah, maybe.
In Taipei.
Maybe he gonna have the work. Okay. The 10 statement in the name of the work. So basically it's the work with, how can I say, a tiny railway toys with very bright LED and everyday objects. So you could see now how it works. So here is train and there is object. So I think it's just normal eraser.
yeah.
This is the, how can I say in English, you know, the stuff for putting maybe across it. And this is trash can. And this is spring toy for kids. Buildings of pencils. This is my favorite part. So it's just shadow and light, but you could easily feel it's really kind of the, how can I say, the very, very interesting feeling that almost like you are on the train.
Mm-hmm.
In the same time, you could also feel that you are outside of the space. Yeah, this is great.
Yeah.
I'm not sure when is his next exhibition at Taipei, but right now he is quite active all over the world, so maybe you could have a chance to have his next work, maybe in next year or another. Yeah, basically he just used a very cheap everyday object right now, that one is just for decreasing and relapse. I'm not sure. For example, in Japan we have a 100 yen shop.
Oh yeah. We do have. We have $10.
Yeah. Daiso or other. So he mainly used Daiso for getting his materials. Okay. So back to slide. Okay, so there are 3 of 19 faculties, so we working together and teaching the students together. So maybe you could imagine some part of our work. Next I'd like to talk to you about my first, how can I say, experience at Yamasuda. When I was undergraduate, they had a lecture of MSP summer school, and in 1999. And at the moment I was in Kyushu, another university, to study acoustics. But one of the guy, Akamatsu-san, is right now he's doing an iPhone, but at the moment he's really good to doing a Max MSP. And Max MSP is the environment for mainly for audio and interactive programming style in a visual way. And at the moment MSP is just developed, and he invited the original developer of Max MSP. His name is David Zicari from California, and he had one of the world's fastest lecture summer school of the Max MSP at Japan, Yamas. And I was, at the moment I was undergraduate, but it was really, it looks really interesting for me. And I use that programming, but there I'm only one who use that stuff. So I decided to come to EMS, and then I made lots of friends out there. So it's that was my first experience at EMS. And by the way, how many of you know Max MSP?
How many of you know Max MSP?
Okay.
Raise your hand.
If you know Max MSP, you should know Akama-san. Before the day, he developed lots of AKA objects. For example, AKA V, using a V controller within Max MSP. He's the developer of that one. Anyway, Max MSP. So, how many of you know Grasshopper, Rhinoceros?
Grasshopper, Rhinoceros, Rhino. Yeah.
Okay, good. Maybe 50. Okay. So basically, the Max MSP is very close to the Grasshopper.
Mm-hmm.
Just the difference in architecture, sound, and both of them are visual programming environments, and it means they have some. Daito is one of the graduates of our school, and recently he's really famous in interactive work. So basically, Max is programming environment, and but instead of the standard programming environment like C or Java or other stuff, they use kind of the visual objects to create a program. Maybe people about the video later. So basically, you could create a programming with how can I say with a collection of small tiny objects. Maybe I could show you an example. This is Max.
Max is a graphical environment for music, audio, and multimedia. The main document type in Max is called a patcher. A new patcher creates an empty window in which you can connect objects to create complex interactions. Objects are selected from the Object Explorer. Different objects provide different functions. Max ships with over 700 useful objects. Let's create a button. Objects can be resized, moved, duplicated, and connected with patch cords. Test your patch interaction by locking the patcher.
This is the way to use Max, connecting objects with code.
Max objects communicate with messages. The button object sends a kind of trigger message called a bang. We can use a bang as an impulse to do things, like produce a random number within a specific range. Let's connect a number box so we can observe the output. Now when we click the button, we get a random value. Or we can count bangs. This counter object will count from 1 to 4 every time it receives a bang. We'll use another number box here to look at the output. Now every time I click this button, the counter will increment.
So as you could
It would be
see,
useful if
it's kind
something
of
could pulse
easy
this button at a
problem
steady rate.
And especially it's
Let's generate
very
a
good
pulse
for,
with the Metro object.
in interactive
In this
stuff
case, Metro will
in
set a
real-time situation, and
the Metro
at the
object
beginning of
needs
the
an on-off
Max is
switch,
the
so we'll add a
musical
toggle.
tool, so they have lots of objects,
Find
and
out more about
each
any
of the
object
different
with a
functions,
call
and then the
function.
number of the function around
This
about
gesture
the sound
recalls the
is
tone
really
file from
huge.
that object.
And they also have
Working
a
patch
object
window.
for images, movies, 3D stuff. Recently, the number of 3D stuff is getting increased, so you could easily
Tutorials
work
and
with
vignettes.
OpenGL or other programming environment with Max
The
MSP.
message box is a common object in Max.
For me, like,
You can write anything you
it's
like
my
in the
first
message object.
programming environment,
Click on it.
so
The message
I'm
is sent
really
to the receiving object.
I used to
Once you use
recently
the
I'm
message
not so
object
much
to load
doing
a
the Max
movie.
MSP, but in these 10 years I'm mostly doing Max MSP to create our own work. So
We
I'm
can
gonna
create
show
a
you
message
some
to
of
jump to a
my
specific frame.
past work as examples of Max MSP. So first one is the sine wave orchestra. It's the project with 4 people, including me, and we started the project over 10 years ago. But basically, we just use sine wave. I suppose every of you know sine wave, the shape. Yeah, if you study the mathematics or
You know sine
physics,
waves, right?
you should know.
正
I
学
suppose.
波
If you're an engineer school, you should know the sine wave, but it's based on the
You should know.
acoustics and in our project we just use sine wave, and basically we don't perform in the project, but instead we invite people to perform sine waves, and in each work we asked them to use a sine wave for each in a very different style, and every time we made different instruments or installation to play sine waves. And this is one of our kind of historical work. The sine wave orchestra stays the name of the work, and we did the work in an anechoic chamber room. In the room we have 116 speakers around the room that looks like this, and we control the whole systems with Max MSP and other programming environment. So I could show you how it works with movie. Yeah, we did work around 2005, which means 8 years ago. So it's kind of old school interactive work, but you can see DSS. In the work, we have 2 controllers in the center of the anechoic chamber room, and one is for changing the frequency of you could listen, and one for changing the position. So it's very, not stereo, but we have 116 channels
Yeah.
with speakers.
So
Yes, very dynamic sound. And then in the work, you decide the frequency and the position, and you read a sine wave as a kind of instant of yourself and the space. So at the beginning of the work, there is no sound. But if you came to the work, there was a sine wave. And if next person came to the work, we could have 2 sine waves, and we could accumulate the sine waves over the exhibition period. And at the last, we have around 3,000 sine waves, the collection of 3,000 sine waves. So, the concept of the work. and that sounds like this. And in that work, we use Max MSP in this way. So it's kind of system diagrams. We have 116 speakers, and with how many? Yeah. Here we just have a 4 audio interfaces, but we have 5 or 6 audio interfaces. We each have a 24 output channel, and we do Mac, and one for some synthesis, and one for the control. For control, we use Max to create the input from controller, and we also control the light in the room with Max MSP. And for some synthesis, we use another programming environment, SuperCollider. It's named audio synthesis programming environment, and it works in a very traditional style, like a text wave. But at the moment, the sound quality of SuperCollider is better than Max. So
Oh, really?
yeah. Recently, the sound quality of the Max MSP is getting better and better. At the moment, we prefer SuperCollider. So we decided to connect these two environments through network. And, yeah, it's really hard to see, but we have an inside cable between the two Max and control the ending with OSC, the Open Sound Control, the control environment for communicating between the programs.
So sound was generated by the synthesis?
Yeah, synthesis. So we in our project, it's just important for us, but we are really kind of the synthesis, real-time synthesis. So we don't want to use the recorded sound for our work. So
In other words, you're not using analog?
no, in this project we didn't use analog, but some project we use just analog. So we build a custom oscillator with solar panel and provide the stuff for each people. Yeah, so
And the reason why we have the MIDI machine is...
MIDI machine to control light.
Lights, oh.
And we have, I use some artwork, but at the same time I'm teaching at university and I'm kind of a researcher, so it means I need to write a paper. So not every time, but most of the time after I finish making the work, I wrote about that work as a form of paper. So it's the kind of my way to survive in the academic and art field. So maybe it might be nice to know.
And this is the institution under NCTU?
Yeah, and I did the work
It's
at
like
the
the-
NCTU Communication Tokyo.
It's like their R&D?
No. Actually, the NCTU Communication Center is not belong to the NCTU itself. They have a museum, interactive installation museum. Recently they have budget every year, so they still alive, but they suffering. Okay. And next one is it's kind of different work with another guys, Yamatsukai and Taiji Sawai. It's more like a performance work, so I could show you video of the performance. It's very kind of the experimental, extreme, primitive, technological work. Okay, this is the short clip from our performance in 2008. basically, we started the project in 2004, and at the moment we have no controller or other accelerometer built-in devices. So at the moment we made, and actually I made the sphere. So that part of my work, and Taiji made sounds, and the guy performed. And in that work, I also use Max MSP mainly. And within a sphere, we have accelerometer, distance sensor, and light bulb. And every stuff is actuated with Max MSP through an audio signal. If you're interested in that work, maybe I could give you a PDF to teachers, so you can easily see the details. Maybe it's kind of the last example of Max MSP. So it's another work. It's not so much related to Max MSP, but it's really related to the image and sound. With this project, we made a code to translate the image to sound and the sound to image. And if you're familiar with the RGB or sound sample, you can easily understand. We just convert the RGB of each pixel to each sample of the sound, or vice versa. So each sample of the sound to each pixel of the RGB. And with that program, we made a installation again in TTICC. With the installation, you could listen your image as a sound first, then you could see the sound as an image. So it's kind of complicated, but at first, the camera took your images. Then our code convert the image to sound. Then the microphone catch the sound to the image. So the sound is coming from the speaker from behind of the So you could listen the kind of the noise, but actually the noise is the image. And you could see kind of a blur around here. And actually the blur is coming from the reverberation within the room. So we could reproduce an image from sound in a kind of a real-time situation. And if you wear kind of striped shirts or something like that, you could easily listen to kind of rhythm between the white and the black images.
And the scanner is?
Scanner is the camera. Camera is around here.
Right here. Okay.
So, and then within the work, it's really interesting. If you use a really nice camera, you could have a really nice broad spectrum of the sound. And if you use just cheap one, you could have very cheap sound. And it's also same for the microphone or speaker. If you use a really nice microphone, you could have a clear images. But if you just use a very cheap microphone, like the built-in microphone in a PC, the image is not so clear.
Can you talk backward? Like you have generated this sound and you have recording and turn it back to image?
Yes. And actually we did the installation, but we also made plug-in from audio application and image application. And with the plug-in, you could use, for example, you could use some audio effects like a reverb or equalizer or delay to your image. And you also could use some image effects like RGB tone curve to sound. So you could have a diverse effects from the both sides for your image of the sound. Then you could use the plugin in kind of standard application like if you use the sound, logic from Apple, we could use the plugin with Logic. So you could use lots of the audio, image effects for your sound. And some of my friends made a album with our software and they released. So yeah, but basically the sound sounds like kind of noise, not the very nice, the popular music. So most of my stuff is not kind of that style. So
it's like encoding or decoding
yeah,
the image into sound.
Yeah, and it's kind of complicated work. But in the installation we use 3 Mac and two for the application, our original code, and one for controlling, like the kind of system diagram. So at first we could catch the image with camera, then convert the image to sound, and then produce the sound from the speaker, and then we catch the sound with the microphone, and we convert the sound to image through the projector, and we control the whole system with Max MSP. And we did the installation for 1 year, so kind of the semi-permanent exhibition. But thanks to our code and Max MSP, we have no maintenance at the moment. We just leave it and it keeps working for 1 year.
Wow.
That's great. And with that kind of experience, right now we are making installation at LTCB in the center of Taipei with noise architects. And this work, the name of the work is the Philip Mata. And with the work, we have 400 flip about in the surface of the building, and we control every flip with programming. Basically, we use Max MSP and processing for control. And this is a prototype of the flip.
The ambulance sound is not part of the work.
Yeah, the sound is not part of that.
救护车声音不包括在内哈。
Maybe just skip.
环境音效。
And basically, we actuate each flip with the air pressure, change of the air pressure. At the beginning, we are thinking to use the sound motor, but it's kind of the public installation in the outside space, so sound is really dangerous for that situation. So we changed the system to use the air pressure. And right now we are almost finishing stage. Maybe hopefully next month.
Next month, when it's been installed?
It's going to be completed in a few weeks.
Wow, okay.
Supposed to be.
Wonderful.
We've been saying that for half a year.
And that's why I came here, basically. And in that work, we also use the special equipment, the hypersonic sound systems. It's kind of a very limited directional speaker, maybe you already know. We put that stuff. This is a speaker, and for the speaker we use servo to control the position. So that, and right now we have 4 speakers. So under each unit we situate the speaker, and it also relates with the movement of the flip and to generate sound. And
You're saying it's been driven by air pressure.
It's not the air pressure, but these are moving by air pressure. So and here we couldn't see from the image, but we situate the 4 speaker around here.
And is there enough difference or variation in air pressure to drive it? Or
Yeah, we could do. We did it with the air pressure there. I'm not in charge of that system, but the
Pneumatic system is more durable and stronger than collectible for the longer span. Especially this is outdoor installation.
Right.
Whereas the servo motor, you can't guarantee more than 3 months. That's too short.
Probably only 1 month.
Yeah, I would say.
Demo. Is it okay to show the demo
Yeah, sure.
for them? Okay.
Please.
We should have one of those installed in front of the president's office, facing it. When we have
Asking for
something,
money. Asking for
yeah,
money.
when we have certain images to send to the president.
Okay, so this is the control codes built with processing by Horikawa-san in a noise architecture. And this here is my code. Yeah, this is the maximum speed. Basically, it works with kind of light game AI stuff. It's like this. It's simulator, but it works fine. And here we have OSC to communicate with processing and maximum speed. And basically, we are in our idea we use the sound from earphone because that sound is really rhythmic and sounds quite nice. So we just use the catch the sound of earphone with microphone and produce the sound through the hypersonic speaker. But in a special occasion, we also use some numbers and voices with our system. Here's special system, like there is number, and when we activate the number, we have some number with scripts. Okay. Let's see, and we also have time here. What time is it now? It doesn't work there with the simulator, maybe because of 3D. But we also have some words like
祝好运，祝好运，祝好运，祝好运，祝好运，祝好运，祝好运，祝好运，祝好运，祝好运，祝好运，祝好运。
Actually, the whole sound we divide the whole system into 28 units, and for each unit we record the other people's voice. So we have the 28 people's voice with the hello. So maybe we'll have some other stuff like that.
Hello, 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 hello,
So you could
hello,
listen.
hello, 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 hello.
Okay, so, and it will come hopefully within a few weeks. Yeah, we're gonna change the content of the sound, but okay, so when I finished my how can I say introduction of the EMS and Max NSP, and next I'd like to show you my current ongoing work on cutting record. So from that I'm gonna do a performance. Toda-san already know, but
这是一台切割机，切割纸机啦，像割纸机。
I'm gonna make a record. Yeah. Let's see.
You could really make a record sound from scratch.
So,
really for
I suppose most of
做
you
唱片
know
做唱片。
the program.
然后用这个播。
I mean, this is actually considered as an art performance, so you're getting a free art performance.
唱着。在illustration 很强哦。
不是很强，是。
各位，你们这样看得出来他在做什么了吗？看得出来吗？稍微看得出来举手。稍微看得出来哦。后面什么完全还不知道他做什么。他没有用滑鼠哦，他是用触控板。
我说他可以用触控板开车。
对，他也是，都可以跟着他这样。
对。 唱盘。
对。This one?
Okay, so I just would like to explain about how it works. Maybe you basically I show you every process. So
Definitely.
yeah. But you Sony, I just use Adobe Illustrator for making a record. Is Final Cutter, and I'm not sure that if you're familiar with that machine, but it's quite cheap. They're just about $200, so it's almost like a standard printer. And I suppose most of you could use Illustrator or other similar vector graphic environment like Inkscape or other stuff. Back to slide. So basically, the record works in this way. So, and this is the very standard, normal, very cheap record player. You could listen the record, every record player. And basically, the record player, every record player has a stylus out here, stylus, and every record has a groove on the surface. So when stylus moves along to the groove, it vibrates, and the vibration make sounds. That's the basic schematics of how record works. And I just use that technique for our project. And this is kind of the history of record at the beginning. Actually, most of people just saw the Edison is the first guy who made records, but it's not true. But after 2008, actually, in 1857, Raymond Scott, French guy, made phonograph. At the moment, it was just a device to visualize sound with the lines and the papers. But in 2008, some French Canadian researchers succeeded to reproduce sound from the image. So from that moment, the history of the recording is changing. And this is quite famous. Thomas Edison, he made a phonograph in 1877, and it used cylinder instead of the flat surface. They use cylinder like a toilet paper stuff. and to put the sound in a vertical way. So it's a bit different from that stuff. It used the horizontal way, but Edison used the vertical way. And it's really difficult to reproduce the records from the cylinder because it's really hard to copy the cylinder to another way. And for the problem, the other guy, Thomas Bernier, Emil Bernier, he invented gramophone. It's almost same as the current record. So he, instead of the cylinder, he decided to use the flat surface and he put the sound in a horizontal way. And with this technique, you could easily have some cast from the original. Then you could easily reproduce the sound in a very engineering way with metal cast and some combiner stuff. Basically, we just follow his way, but instead of cast, we just use this spinal machine, spinal cutter, or laser cutter. As you see now, I said this work in the name of record, but as you saw it, actually it has no previous sound, so it has no recordings. You could listen the sound from the paper, but there is no original sound. We just have original vector images. And when I invented, I didn't know that stuff, but after I developed that stuff, and I checked some literature about records, and I found this essay by Laszlo Moholy-Nagy, the master of Bauhaus, in 1923. He wrote an essay to produce a record without prior acoustic information. And at the moment, it was just idea, but to be honest, I could say now after 90 years, we made his idea in a real situation. And it's really interesting for me. He's the guy. Mainly at Bauhaus, he's really good for doing photograph and light and shadow installation stuff. But he also did some audio related work. Bauhaus, maybe all of you know that school. It's very one of the first design architecture school in the world. We have lots of influence from the school. And in our work, we basically use the vector graphic software and cutting machines. So cutting machines means a laser cutter or binary cutter. And the laser cutter is relatively kind of expensive, like maybe the 100 times expensive to compare with the binary cutter. But I'm not sure if you already have.
Yeah,
it's like so. Okay. And I also use laser cutter for our work. And here's some example. It's really hard to take laser cutter with me, so I just took the outcomes. So for example, it's the root records. The wood records came from our workshop, and we did workshop at Seoul with the undergraduate design student, and they just have experience in Photoshop and Illustrator, and they don't know much about sound. But during the workshop, every of students made her or his own record within 2 hours with just Illustrator and cutting machines, and after that we made compilation of their records. Wow. Right now we have 100 records without pre-acoustic information. So, and here is the record with cardboard.
Cardboard. 几百。
the hole is too big, so it's
too big.
yeah, too big for that player, so it doesn't work well. But anyway, and so for that type, I just produced a record with Adobe Illustrator. But after that, yeah, maybe you also think that idea, but we also try to use the real sound, recorded sound with our technique, and we did. This is the results. So for that record, we use laser cutter and our original code with processing. So we import the audio data, ECM WAV file, into the processing and create vector from each sample, and then cut the vector with laser cutter.
Okay.
So it's just 1 minute, but it takes about 1 hour for cutting.
Okay.
So, and it's acrylic, but you also could make it with paper or wood or other stuff. So right now we have a chance to make your own record with diverse material if you want.
Wonderful.
Yeah. Yeah, and this is another one. It's kind of hard to play, but I also made record in a kind of the puzzle style. So instead of making one circle, I just split the circle into arcs in a physical way. So in each arc you have a different sound, and you could change the sound with the order. So it's almost like kind of the sequencer, step sequencer in a very analog way, and I hope that it will, yeah, and I think that, you know, the hip hop music, that it used the turntable in a scratch and other way, and it make turntable into the musical instruments. And with this technique, that we could use the turntable in another style of the musical instruments.
Right.
Okay. And actually, doing the strange things with record is not new. Actually, in 1920s, Japanese comedian made record with rice cake. Yeah, it's very historical. This is record made with chocolate in 1980s. And they have a movie, so it might be nice to see. This guy, he used cast, so he make cast from original record, and he put melted chocolate on it. You go easy, just like we need to have a refrigerator. Yeah.
That's not good.
Some are currency, so This is another one. It's the final video by Gerhard Stengmuller, German artist. And in this part, he put the signal of images, videos on the as an acoustic signal on the record, so you could produce moving image from the record or ice records. Yeah, it's made by Japanese artist Ryota Yagi, and the technique is quite same for the chocolate, but instead of the chocolate, he used water.
Wow.
It's really beautiful work. Last time goes by, the ice is melted and it disappeared. And another people also made with a cut record, and they did really nice documentation about their project. It's totally better than us, so you could easily check their results. But the technique is quite same, almost same. They made wood record with. I just use MDF, the cheap wood, but they use a very nice wood for their record, so looks better than ours. But sound quality is almost same. Not so good, to be honest. In relation with recent personal publication or maker movements, we put the whole of our stuff not only in the form of academic paper, but also in the form of different way. For example, now, maybe some of you know the instructor with the whole collection of instruction all over the world, and we put the process, as you saw in, we put the whole process in the instructors, and we also upload our data in the form of AI or PDF as a compilation of the record with a pre-acoustic information at Thingiverse. Thingiverse is the website for data, not data about 2D, 3D, and other style. And recently they are also quite popular. GitHub, we also put our code with processing at GitHub, and here you could know the detail of our code. Almost ending. And I think not only our practice, but also the other practice in these days is a kind, especially in relation with music, is kind of the emergence of rewrite culture. I'm not sure how many of you know the Creative Commons, but it's quite popular in Europe. You're here. And Lawrence Lessig, he's the originator of the Creative Commons, and he's lawyer, and he wrote about a book about remix in 2008, and in that book he's talking about rewrite culture, and rewrite culture is kind of the culture in this century, and he said in the book, and in the last century we just have a read-only culture. It means that we just consume the stuff from the commercial company or big artists or other places. But in this century, we have lots of technology, for example, internet. And with that technology, we could produce not only the consume, but also could produce stuff in a very easy way, like artists. So, especially in relation with music, it's very kind of the dramatical changes. In the last century, it's really hard to produce record by yourself. If you have some special interested to make a record with chocolate or rice cake, you can make it, but it takes lots of time and it's really hard to do that. But in this technology, it's not so hard. If you have the proper devices like a vinyl cutter or illustrator, you could easily produce your own records with very cheap budget. Like for example, in the case of paper, it takes just, how can I say, under $1, maybe 5 cents or around that. With this kind of technology, I would like to say that we are changing, and we could go into the next step of our culture. And from musical point of view, I have a favorite quote from musical point of view by Jacques Attali. He is French economist and philosopher, and he wrote a book about music, economy, and noise in 1985. In that book, he said, I told you that to include the quote, music is prophecy. Its style and economic organization are ahead of the rest of society because it explores much faster than material reality can the entire range of possibilities in a given chord. So I hope that this, it's just example of the one. It's just one example, but I hope this stuff will continue, and I hope that other fields like architecture, design, product design will follow our way to produce your own style in a different way from the last century. Okay, thanks.
Is this amazing or what? This is truly eye-opening or ear-opening. Any questions? 有没有什么问题？那我们征求3个问题好了。没有？有疑问？
Yeah.
In the project name Shadow of the Sound, have you ever reversed that image from a beautiful picture or?
Yeah, we did. But the beautiful picture sounds noise kind of because there's no relationship from the beautifulness and the order of the pixels. So it's really hard to have nice sound from beautiful images. But if you have some, how can I say, geometric shape, like a black and white stripe or other gradation. So gradation is really nice for the sound because if you have a gradation from black to white, you could easily have the change of the pitches with the gradation because it changes the amplitude gradually.
In other words, have you ever changed the beautiful sound like some beautiful music into image? How's it like?
Yeah, actually, if you have very basic sound like a sine wave or a square wave, it makes a kind of really nice image like a geometric shape. So if you have a sine wave, you could have really beautiful gradation from sine waves.
Was it because?
Because the sine wave has a change of the amplitude in this way, and if you change that change of the amplitude to pixels, the amount of the RGB value of the pixel, you could have a gradual change of the RGB value. So from white to black, I think.
So does that mean it's because it has a more, say, harmonious?
Not harmonious, more like
more gradual change.
Yeah, gradual change.
So that it becomes more coherent or
coherent, yeah, it's
or
coherent.
logical in the representation.
And it's very logical in the form of representation.
Does that also imply there could be possibility for a new type of reader?
Maybe.
So you can read more complex, let's say, painting.
Yes, I think so.
So read multiple logics, if you will. Yeah.
Yeah. Maybe I have some images from sure.
I have a probably very simple question.
Yeah.
Could be complicated. The use of a sine wave
Yeah.
at this point is because it's simple
Yes.
and more recognizable.
Yeah. Yeah. Yeah.
But when it was practically limited by the reading facility. If the reading device, if you will, or mechanism can become more complicated, and let's say Max SP is still able to handle it, let's say, assume, then it could read something more than a simple sine wave.
Yeah.
Has there been other school or institution been trying in that direction, going beyond just sine wave?
About record?
Not about the record, I mean the study of the sound.
A study of sound. Yeah, there is a lot of the study around the sound, for example.
But going beyond the sine wave level into more complicated, let's say music notes, music tones.
I think there are lots of people who doing musical recognition and other stuff. For example, in my undergraduate school, the name of the school is Kyushu Institute of Design. It's part of the Kyushu University at Fukuoka. And some of our teachers doing that kind of musical recognition stuff as well. There's kind of diverse field of musical recognition research.
And are they doing the same thing, like trying to translate or transcribe the music pattern into visible form? That's probably more my question.
There is field of sonification.
Yeah.
The field is the visualization.
Yeah.
Right.
It's the counterpart of visualization with the sound.
Yeah.
So that people try to produce the sound from the lots of data information. And in a same time, in a visualization study, the people try to visualize the relationship between the music and sound in a different way. So maybe some of them are not so logical, more like they have some interpretation.
Oh, okay. Right.
But some, for example, if you use the iTunes visualize,
Right.
so they have a kind of logical visualization within iTunes.
Yeah. Funny stuff.
Yeah. So we have some, but I'm not sure that we have in logical, not just one way, but maybe
As logic as RGB.
It would be great to feel for next research.
And how is the RGB sort of set up for the sound?
Actually, if you open bitmap file, it's extension. See the order of the top. But actually, the reason why I use sine wave is simple enough for me, but the standard music is too complex for me, so that's why I use sine wave.
Sine wave is the most simple.
For me. And that's why I'm doing this kind of stuff. So I try to play other musical instruments, but it's really too hard for me. So that's why I choose the very basic stuff.
It's more like a synth music, sound synthesis, but in a physical form.
You mean that one?
Yeah.
That's true. Actually, it mainly generates kind of sine wave.
Yes.
But basically, the sine wave is coming from the electronic circuits. But instead of electronic circuits, it's just the sine wave is coming from graphical form. And as you said, it's kind of a new technique for sound synthesis.
Well, I can see a lot of possibilities from this.
Yeah. Please.
Because since you use a very basic feature of the records, like you have groove.
Yeah.
So I'm just quite curious, what if we find anything which has groove? Like you have the woodcut,
Or different texture.
Yeah, with different texture, or even we can have like branching. Since right now we have only one track. At a certain point, you just
I tried.
You let the machine to decide.
I tried to make this
Oh, really?
kind of the shape, but it doesn't work well. Basically, I opened the whole process of the work, so please just take some part of it and then please
Okay.
try to use the stuff in your work.
Okay. Wow.
It's my pleasure.
Eye-opening.
Yeah. I'm not so much fan of patent or copyright stuff, so
Yeah.
The range of possibilities is immense. I mean, if you replace the physical stylus with optical,
yes.
then
Yeah.
it explodes. Okay, great. Any more questions? 还有没有其他的问题 Okay, well then let's. Oh, okay.
So I think that is a kind of the parametric design of the music. If you use the Illustrator or some processing, just like the architecture design into the digital era, and that's the parametric type of the music created, right? And do you think where it goes, the music goes to, which the future with this technology?
Is this technology?
Yes.
You mean the music?
Yeah.
What does this lead to in the future?
In the future, personally, as I told you with the slide, I really like to have a kind of the culture to make your music by yourself. So not just listen the sound, the pop stars music, but also create your music. And that music itself is not so good for every people, but like cooking. So for example, if you cook by yourself, the quality of the cooking is not so high level, but it's good for your family or your lovers or your friends. And I hope that the music is for that way. So not just consume the music for 100 or more million people, but to play or create music for just few people. And it works.
So is there any connection between the image and the sound? So we can figure out how to draw a line so I can produce the music or the sound that I want.
You mean with the record?
Yeah.
Yeah, it's actually very easy to read. If you see the surface of the, maybe you could see the surface. You could see the waveform.
Yeah, I noticed there's a bit kind of a bass line.
Yeah, and
is that corresponding to the visual cuts?
Yes. The relationship between the sound and the image is quite clear. So, for example, if the record 100 wave, 100 vibration, that if it turns to 1 second per, 1 turn per second, and if you have 100 waveform, you could have 100 hertz from the change of the from the vibration of the stylus. So if you have a 200, you have a 200 hertz. And if you change the number of the wave, you could have a different frequency. That's why I put the different number with Illustrator for zigzag. So you could, maybe I could show you the image. Let's see.
所以大家懂那个原理吗？你转那个唱盘不是只有转速吗？1秒就是1分钟转几圈，等于说它距离经过多少？那假设1秒钟经过这样的距离，那里面它有那个 sine 的波有震荡100次的话，就是100 Hz 的意思啊。
This is the instruction.
那转成这样的话，就会有声音的那个
for how to make a record, and I also put the instruction on our website as instructor, so you could easily get it.
This is on your website?
Yeah, at instructor. Yeah, and here. Here is the
frequency.
Yeah, frequency. If you try to have like a 440 hertz, and if you split the axis into 16, you need to put the 50 for the number of the zigzag here. And you could have this frequency, and if you'd like to have a higher pitch, you just need to put more
So
zigzag.
double that,
Yeah,
from
double,
50
yeah,
to
140,
440
yeah.
to 800.
It's very logical.
Responding
From each stage.
Yeah.
So double.
There's no complex signal processing.
Right.
You just have a very basic physics.
应该算简单嘛，对不对？
First generation of the synthesizer.
Yeah,
You
almost.
have this sound generator and then the ADSR.
Yeah, and the ADSR too. You could also have some drum-like sound if you
Attack and
draw
waveform.
Yeah.
Right.
Yeah.
Okay.
And then we tried and it works.
There's still people using that.
What do you mean?
The first generation
Yeah,
of the synthesizer.
they still use.
In a way that like Daniel Libeski tried to generate the diagrams and stuff. It's
Yeah.
in concept, he's trying to do this kind of thing. If they had a computer, he wanted to do the graphic composing into the music, but of course by the time they were such a device. But now it's becoming like
We can almost call this soundscape.
right. Graphic design of sound.
Is that
And there is no space for interpretation. It's very logical, just right.
yeah? Unless it's chocolate.
But you could ban it actually, like a Jimi Hendrix.
It's wonderful.
Okay.
I have a question. Have you tried to use the different lens for the laser cutting?
Yeah, actually,
Does it
Yeah.
does the outcome come out to be because the different types
Yes.
of lens will have an impact?
yeah. Actually, to be honest, for that record, I use special lens. The standard lens is too broad
Yeah.
to make the elevate the
Probably like the
height.
1.5.
Yeah. It's not 1.1, more the
It's more.
yeah.
It's 1.1.
From Universal.
Yeah.
Have a
Oh, okay.
MD. HFD, high definition, something like that.
Oh,
It's
I
kind of
see.
an expensive one, but I
Yeah,
bought
yeah.
it and it
Oh,
works
I
with that one.
I see. And then the sound quality is.
Sound quality is still not so good, but it's better than the standard
I
range.
see.
2.0 doesn't work.
Yeah, the typical 2.0.
Yeah, because you have lots of melt with the
Yeah.
surface one. So,
Ah, I see.
so
同学，我们今天还有特别来宾，那个金旺，他是台北那个 Fab Cafe 的 owner，然后他是以身体来见证台湾的未来的，因为他是香港过来的，
我也是建筑背景。
对。
哈佛 GSD 毕业，可是他选择到台湾来，然后告诉我们台湾人说，连香港人都要来。对呀，天旺他这边也有常常办很多活动，这个都跟创意有关，然后他也有组织一个 maker。
对，我们现在是在跟不同的朋友在建立那个 ecosystem，因为
network。
对，因为其实，在台北已经有很多不同的朋友在 spring up 有一些 idea。对。
所以上次我看到他们跟Barcelona、Tokyo 和 New York。
Barcelona、Tokyo 跟我们三个
连线，然后3个地方的 maker 都出来在修东西。上个学期有修过我的课，他们就跟那个谁啊，Barcelona 那个
Cecilia，
对，跟 Cecilia 有连线，有没有 ？Mom。Okay.
Okay.
All right.